Thank you, guys. This theater is incredible. I mean, we're so lucky to have a conference and a venue like this. Thank you, Ashkan and the Float On boys. This is an unbelievable undertaking, organizationally speaking, and they pull it off every year. It's just fantastic. But today we're going to talk about something that's very near and dear to my heart. You know, I think we all see this in our float centers. But anxiety it's so ubiquitous, and people need a break from it. They need a respite. And floating provides that. I think it's very clear it does. It just hasn't been well documented, and that's what we're going to be doing. So let's talk about this journey. It actually started 3 years ago. That's the old stage for the Float Conference. I don't know if people remember when you had a pyramid of salt stacked a mile high. Those were the days. Now you get all these fancy float tanks. So back then I was actually at Caltech. This idea was a dream, and as Colin said, we had no idea how the hell we were going to accomplish this. And it was through a series of serendipitous events that I ended up, just shortly after that float conference, moving my life from California to Oklahoma. Laureate Institute for Brain Research. And they gave me the opportunity to build this dream, and Colin is really the visionary that saw it through. So thank you, Colin. There he is, 1 month later. It's freezing in Tulsa. And actually there's Jim too. You could see Jim and Colin's wife, Jenny. But we're just saying, you know, how do we do this? There's no map to follow. There's no precedent to follow. And it started there in January. That summer, we just started construction, put it all together. And then really September of that year is where it came true. We installed our first float tank. It was the open pool. And those are my collaborators at LIBOR. So this is Dr. Martin Paulus. He's the guy who brought me over. He was my original mentor in neuroscience. He ended up becoming the scientific director at LIBOR and brought me into the fold. Right here is Saib Khalsa. You're going to see a presentation later today by Dr. Khalsa unveiling the first clinical research we're doing with floating. And this so happens to be the first day that Saib floated in our open pool. And he was the first floater in the open pool. And it was after that float that I think I convinced him to leave UCLA and join forces at LIBOR. So now Saib is working at LIBOR and helping critically with all the float research. And then last year, you heard from Dr. Kyle Simmons. He couldn't be here this year, but he gave a great talk that I think has a lot of relevance to what I'm about to tell you today. So it took about 6 months. Colin and Ginny essentially lived with me. And we figured out how to measure everything we wanted to measure during the float itself. And then finally, May of 2015, we launched our first float fMRI study. And we're going to be discussing that today. And here we are. 3 years later, the dream to study how floating works in the body and the brain, it's finally here. And I can't wait to share some of the first results with you guys. Now, having worked at a lot of different institutions, I could tell you, 3 years is actually not a lot of time in science. And the reason it was able to happen at this rapid speed is because of this place, Laureate Institute for Brain Research. It's a clinical neuroscience research institute, a nonprofit. And we have a pretty bold mission. We're trying to reduce suffering in those with mental illness. And we're trying to think outside the box or I guess in this case, inside the tank, to come up with new ways of combating mental illness and really improving mental health. And because it's a small institute, because it has some incredible facilities and resources, we could do this at a pace that was unprecedented. And it really happened quite quickly, and we're very fortunate to have LIBOR. So let's just start. What is anxiety? I think the first thing we have to recognize, this is part of our existence. You can't dissociate anxiety from life. Everyone has it to some degree. I mean, does anybody here know somebody that's never been anxious? If you do, I want to meet these people. In fact, I spent the last 10 years trying to study people with brain damage to very specific circuits in the brain. And even people who are missing the circuitry that we have all thought to be involved in fear and anxiety still showed manifestations of anxiety. They're missing their brain regions that are supposed to be involved in it, and they still were anxious. I don't know if you could be alive and not have anxiety. That's the truth. But it might be healthy to some level. It might help inspire behavior. It might help you get through stressful times by encouraging you to do something. But the problem is, our society is being morphed. It's overtaking us. I'm going to talk about this later, but technology is rapidly transforming our culture, and I think it's actually heightening our anxiety. And this is what's so bizarre to me. We're living in a time where all of our basic needs are taken care of. This should be the least anxious time in the history of human civilization. Yet I think we're ridden with anxiety. And this is where floating, I think, really provides a solution. So a lot of people don't know this. It's the most common psychiatric condition, about twice as common as depression, although they often go hand in hand together. About 40 million people have a full-blown anxiety disorder. What does that mean to have a disorder? It's not just, I feel a little bit anxious all the time. It's when it really impairs your life. You can't have relationships. You can't have jobs. You can't go out and have fun. It becomes so debilitating that some of the patients I used to work with had a condition called agoraphobia. Essentially means they couldn't leave their bedroom. That's how debilitating anxiety could become. So this is what we're hoping to work with. We're hoping to help these 40 million people. A lot of different types of anxiety. It manifests itself in very different ways. Generalized anxiety, social anxiety, post-traumatic stress, OCD, phobias, panic disorder. There's a whole variety of anxiety. But at its root, only a third of these patients are actually getting treatment. That really struck me as a clinician. We are not doing a good job of treating these patients. If only a third are getting treatment, that tells you something about the current state of affairs in our treatment system, right? And so, think about this number for a while. Only a third of 40 million people are actually getting help. And we have treatments out there. I think floating has the potential to be a treatment. But the reason no one's getting treated is because this is what anxiety is. It's avoidance. When you're anxious, when things inspire anxiety, you avoid them. And all these opportunities in life shut down. Your options shut down. Your relationship shuts down. So this is important. We have to figure out a way as an industry to overcome this hurdle. And this went into the design of my float tanks. I think you really have to make an environment that's inviting for people who suffer from anxiety. And claustrophobia is one of the big things you're going to hear again and again from these patients. So let's take a quick look at some past research on floating and anxiety. I should point out most of this was done in healthy people. There hasn't been a lot of clinical research. This is probably one of the most well-replicated effects of floating. When you measure stress and anxiety, it goes down from pre to post float. In fact, there was a meta-analysis about 10 years ago showing a large overall effect size. So it's not a subtle effect, and I think all of you know that, but it's been documented in research. It's not just subjective anxiety that goes down, though. Physiological forms of stress and anxiety also go down. Some of the seminal work by Dr. Fine showed decreases in cortisol, in heart rate, and in blood pressure during the float experience. Now, when it comes to clinical populations, we know a far lot less. This is where we really have to do a lot of work. There's a study done in 1990 just showing that people who had generalized anxiety means you're kind of like the Woody Allen type, you're a worrywart. You're totally neurotic, you can't sleep at night, you're always thinking about what you have to do. So people with generalized anxiety went to this hospital, I think it was in Wisconsin. They just said, hey, we have a float tank, you could try it. Some people tried it 2 times, some people tried it 10 times, on average about 7 times. And then they sent them a questionnaire, 6, 7 months later and said, how are you doing? And the people who were anxious did show a reduction in symptoms, but a very poorly controlled study. It's hard to really understand cause and effect with that design. The Swedish group, back in 2006, took people who aren't necessarily full-blown anxiety disorder. These are what you might call burnout, people who are workaholics and the stress of work kind of overtook their life, and they had to just stop. And they put them into float about a dozen times, and you see about a 30% reduction in stress and anxiety, as well as improvement in sleep, which I think is a very interesting thing that hasn't been well studied. And then finally, a lot of you might not be aware of this, but this year, the Swedish group, Christopher Johnson and Annette Kilgren, published the first, I think, real legitimate study in people with full-blown anxiety disorders. They took another sample of generalized anxiety patients. They had 50 patients, half were randomized to a waitlist control, the other half actually floated a dozen times over the course of about a month and a half. And what they found is not only did it reduce anxiety in the short term during the actual float sessions, which is good, what you'd expect, they followed them up 6 months after the treatment stopped, and their anxiety was still reduced, much more so than the waitlist control group. That's a big finding. And it suggests that we are tapping into the very mechanism that I've been predicting since 2013. We have on our hands a treatment, it's really a physiological treatment, that is reducing all of the anxious states within our body and within our mind. And I'm going to present some data today to sort of highlight where we think this is happening in the brain itself. So that's in each of our heads, I guarantee you. This is the cortex, the outer layer of the brain, and we really don't know how floating affects it. There hasn't been neuroscience research done on floating. So we're just beginning, we're scratching the surface. But just knowing how the organization of the brain works, we could make some predictions. The first thing is, this is what happens to all the sensory cortices when you float. A ton of environmental input that normally is coming into these areas of the brain is significantly reduced by this environment. Vision, hearing, proprioception, tactile sensation, not on here, thermal sensation, it's a deeper brain region, movement and speech. All of these sensations, all of these cortical areas have a significant reduction in stimulation. We know that, because that's the nature of our float environment. So what's left? Well, there's a couple things that's left. One is mind chatter. And you're going to hear a talk right after me about the areas of the brain that we think are involved in mind chatter. But then the other big thing is your body, your internal body, a concept that's referred to as interoception. All the signals that are coming from your internal body, but especially the heart and the breath, are heightened. So rather than being a form of sensory deprivation, it's actually a form of sensory enhancement, but for the internal body. And the question really becomes, how does this happen? How do you go into a float tank with a lot of stress and anxiety, put your brain into this sensory reduced state, and you come out feeling a lot better? We need to discover how that's working, and today we're going to get a few clues. So, here's our research center. It all started with our open pool. An 8-foot circular open pool. When you see it, it looks like a giant jacuzzi. I'll bring a patient into the room and I say, if you get into your own bathtub, why wouldn't you get into something like this? The idea is to remove the barriers. And I think these open rooms are great for people with anxiety. Very important. We also have the same exact size pool, but with an 8-foot tall circular enclosure. And one of the nice things about the enclosure is you could calibrate things with a lot more precision. You could calibrate humidity, for example. So those are our 2 pools, but we also have a control condition. It's an active control condition. It's called the zero gravity chair, or what we tell our subjects, it's the float chair. It's a chair with memory foam backing, so it kind of supports your body. It's ergonomically designed to sort of take the pressure off the spinal cord. And essentially, what we're using this to control for is the effects of simple relaxation, okay? What you want to be able to say is that floating is systematically different than what you could do in your own bedroom or on your couch or in a comfortable lazy boy. The effects you get from resting in a float tank physiologically need to be shown as something separate from what could happen outside of a float tank. So this is our control condition. And in fact, what we tell people is, listen, we're trying to understand the effects of reduced environmental stimulation on the brain. We want to see what happens when you're in an environment with reduced light, reduced sound, reduced pressure on the spinal cord. And you could either float in our pool or you float in our chair, but in both cases, you have those basic ingredients. So it's an active comparison condition. We really want to see what is different between floating in the pool versus the chair. And here's how we set up our first float fMRI study. We had 40 people, all healthy, and all of them received a brain scan at the beginning of the study, 90-minute brain scan, and they got randomized to either float in the pool or float in the chair. Each float session was 90 minutes, and then over the course of several weeks, they had 3 float sessions, okay? The reason we didn't want to scan their brain right away after the first or the second one is we didn't want to pick up on the novelty effects. The first few experiences are so novel. So this was our way of trying to acclimate them to the environment. And then on the third float, immediately afterwards, they got their brain scanned again. And so what we're really looking at is what is the difference between that baseline brain scan and that one immediately after the third float? And what is the difference between the brains of the people in the pool versus the chair? So this is our subject demographics. These are healthy, older adults between basically 18 to mid-50s. Pretty well-matched sample size. They were all very thoroughly screened. People always ask, how do you participate in our studies? Well, it takes about 5 hours just to get through this process. We make sure they have no psychiatric history, make sure they're not taking any drugs. And once they pass the screening process, everyone goes through an informed consent process. We use what's called the Western Institutional Review Board to approve all of our research. And this is critical. I think a lot of you are interested in research and how could I do research? The first step to doing real research is you have to get IRB approval. Don't forget that, because unfortunately, if you don't have IRB approval, you'll never be able to get your studies published. And ultimately, that's what we need as an industry. We need more publications. We need doctors who read these journals to be able to understand what's happening with our intervention. So, a couple things to keep in mind. Important things. What we're measuring in this study is not this. We're measuring this. Remember, this is happening about 20, 30 minutes after the float is over. I would love to measure this. Colin keeps telling me he's going to build a float tank that's compatible with an MRI scanner. And you know what? He probably will. And then actually, we had, once again, another serendipitous encounter through an old colleague of Kyle Simmons, who figured out a way to actually study the brain during the float. And you're going to hear about this tomorrow. A wireless, waterproof EEG system. It is so cool. So we're going to start tapping into the during part, but in today's talk, keep in mind, we're talking about the post. That's a 3 Tesla GE MR750 MRI brain scanner. This is the same brain scanner that they use at National Institute for Mental Health. It's a very high-tech scanner, high-resolution images. And then lucky for us, it's less than 100 meters away from our float tanks. That's pretty cool. All it is you go in, you put your head here, you could see a little mirror, and then on the screen, we project things, and you're doing different types of tasks. I'll tell you about one of them today, called resting state fMRI. But I think the point to remember about MRI machines is they're very cool technology. You could get very detailed images of the brain, but it's a proxy of brain activation. It's not measuring directly the brain activation. It's measuring blood oxygenation. And it turns out when the hemoglobin is oxygenated or deoxygenated, it has different magnetic properties, and that's what it's picking up on. So we're using fMRI as our tool, and we're getting ready to launch the experiment. And whenever you launch an experiment, it's important to think about what is the cultural context under which that experiment is being launched. And I think this is important because the cultural context goes against the very nature of what we're trying to do. This study, I think, epitomizes everything that we're working against in this industry. This came out in a very prominent journal, Science, a couple years ago. I think I showed it last year, but it's worth reading again. Just think the challenges of the disengaged mind. In 11 studies, we found that participants typically did not enjoy spending 6 to 15 minutes in a room by themselves with nothing to do but think, that they enjoyed doing mundane external activities much more, and that many preferred to administer electric shocks to themselves instead of being left alone with their thoughts. Most people seem to prefer to be doing something rather than nothing, even if that something is negative. I mean, I'm getting ready to launch my study, and I'm saying, you know, people are in that chair room for 90 minutes. They're going to go nuts. What am I going to do? So I met Tim Wilson at a conference actually a year ago. And I said, you know, what was really going on here? And he said, well, you know, we were in Virginia. It was kind of the basement of the old psychology building, and, you know, uncomfortable chairs and vacant rooms. There's nothing conducive about relaxation in these rooms. And then, of course, he's working with college students who can't get off their freaking phones. And this is another thing that we're fighting, these damn phones. People are so scared to detach from them that they think 10 minutes away from them, the whole world's going to erupt. And so that's part of what you're seeing here. They'd rather be spending those 6 to 15 minutes on their phone. So I'm going to show you data that challenges this. This is our first float study, 40 people. We asked all of them the same question, totally unbiased. Overall, how was your float experience? You could answer anywhere from extremely unpleasant all the way to extremely pleasant. The choice is yours. Each of them floated 3 times, so this is 120 data points, okay? And this is their average response on this questionnaire. We only had a single person in the chair who found it mildly unpleasant. But across every single subject in the study, other than that person, all 39, they found it anywhere from mildly pleasurable all the way to extremely pleasurable. What we're doing, guys, is we're actually helping people overcome the cultural zeitgeist of our time. This is important to recognize, and you guys are challenging it in the midst of this technological revolution. Keep that in mind. This is no a small challenge. You will be fighting technology every day of your life because it's overtaken us as a culture, for the better, but also sometimes for the worse. Not only were we improving people's pleasantness, the big effect that we found, probably the single biggest effect, is people were coming out of the float pool saying they felt more serene. I always think of the Seinfeld episode, Serenity Now. But it really actually does change this quite a bit more than it's changing in the chair condition. So it's actually a very strong effect, and you're seeing a huge jump from pre to post float in serenity. When you look at anxiety, remember these are healthy people. So at baseline, before they even begin, they're already starting at a pretty low level of anxiety. If we were working with patients, you would expect them to be somewhere up in this vicinity at baseline. But nevertheless, we still found a significant drop in anxiety specific to the pool condition. So let's talk about the brain. Where is this being registered in the brain? In order to talk about the brain, you've got to know about this network. It's called the salience network. It was only discovered back in 2007, so it's less than a decade old. And essentially, it comprises two brain regions that I'm going to repeat again and again, so you're going to learn these very well. The first is the right anterior insula, highlighted in green. The second is the dorsal anterior cingulate. And here's another view of that. And this is the salience network. Think about this. Our brain is being bombarded all the time with information out in the world, information from inside our body. How do we know which parts or aspects of that information are important? Which parts are salient? It turns out that the concerted activity between these regions in the anterior insula and the dorsal anterior cingulate are sort of deciphering all of this information that's being given to our brain and selecting that part which is important for us. This is called the salience network. And a part of this study that doesn't always get talked about, even though the study's been cited over 2,000 times, is this. If you look at the connectivity between the anterior insula and the anterior cingulate, it correlates with how anxious they were during the brain scan. So now we're starting to get into this idea of anxiety and what are the brain regions driving it. Well, the anterior cingulate's not just involved in anxiety. There was a meta-analysis done, about 192 fMRI experiments, over 3,000 participants. And what you see is the anterior cingulate's activating for all types of negative emotion, for pain, physical pain, for a concept called cognitive control. Whenever there's some sort of error or conflict in your environment, it's trying to regulate that and figure out ways to resolve it. So it's the same area in all of these cases. And we wanted to know what happened to the salience network after the float. So it begins with this brain scan. Imagine sitting in that donut-shaped magnet for 8 minutes, looking at that across, and given the instructions, try to clear your mind and don't think about anything in particular. That's it. Resting state fMRI. An 8-minute brain scan where you're not thinking about anything in particular. And you could do a lot with this. In fact, the next presenter is going to tell you all about a different network of the brain called the default mode. Today we're going to focus on the salience network. So we did the same thing as they did back in 2007. We put a seed in the right anterior insula. You could see here the green circle. And we wanted to see how the connectivity with this seed changed from pre to post float and pool versus chair. And we found a significant group by time interaction right in the dorsal anterior cingulate. Okay? So we know that there's an effect. The question is, what is the direction? And this is what the data shows. So just to help you get through this graph, the pool group is in blue, chair group's in red. On the y-axis is the functional connectivity. How closely connected functionally are these areas? In other words, when the activity in one area goes up, does the other one follow? When the activity in one area drops, does the other one follow? And as the connectivity goes up, you're going to get up over here, and as it goes down, it will be in this region. And you see that you have a huge drop after floating in the pool between these two regions. A huge drop in functional connectivity. The chair group, on the other hand, basically goes up a little bit, but not much. Now what I wanted to do is see, how reliable is this effect? If I take each subject in the study and calculate the difference in connectivity from their baseline to their post-float brain scan, what does that look like? And this is that data. Once again, in blue are the floaters in the pool condition, and red the chair. And you see pretty much across the board, everyone in the pool condition has a reduction in connectivity, with the exception of maybe these two people. And then most of the chair people show the exact opposite pattern, a slight increase. So this was really fascinating to me because it wasn't a subtle effect. You're really teasing apart these two conditions. You have it linked to a brain network that's been very well understood. And now the question I had, the million-dollar question for me is, how does this relate to the subjective experience? In other words, how does this relate to anxiety? And this is what we found. If I take the degree of connectivity change for each person and look at the degree of anxiety dropping post-float, this is the relationship. You see a significant relationship such that the more your anxiety drops after floating, the greater the reduction in connectivity between these two regions. In some ways, this is the most exciting part of the data, because what it suggests is this signal right here is giving us some information about a person's subjective state. And it could tell us how successful the float was on a patient-by-patient basis. So this was very exciting. Let me tell you some more reasons why I'm excited about this finding. Anti-anxiety medication. Study in 2007 looking at, it was basically an experiment that had people undergo pain. And essentially what they found is when you take an anti-anxiety drug, it was a benzodiazepine, and administer it in a placebo-controlled way, you get a significant reduction in these two regions. Guess which ones? The dorsal anterior cingulate and the right anterior insula. We did a study back in 2006 giving the drug lorazepam, another benzodiazepine, anti-anxiety drug, and once again in a dose-dependent manner, you see a drop in activity in the dorsal anterior cingulate. So we're hitting the same brain regions that anti-anxiety drugs are modulating. Kyle Simmons gave a talk last year, and if you don't remember it, I encourage you to watch the YouTube video. It was a great talk. But a big chunk of the talk was trying to discuss what are these regions doing? What is the anterior insula doing? What is the dorsal anterior cingulate doing? And what Kyle actually did is he created a theory called the EPIC model. And what he showed is that these regions are constantly communicating with each other. And the nature of their communication is about predicting your future body state. Not how you're feeling right now, but how you're going to feel a moment from now. And these are the regions that seem to be dysfunctional in people who suffer from anxiety. They're in a perpetual future state in their mind that is totally disjointed from how their body is actually feeling. And this is really the kicker, you guys. Last year, this study was released in JAMA Psychiatry. Identification of a common neurobiological substrate for mental illness. They took 16,000 individuals across 193 different studies using a technology known as voxel-based morphometry. It's looking at the structure of the brain. And they said, irrespective of diagnosis, in this sample are people with schizophrenia, bipolar disorder, depression, OCD, anxiety. They included everybody with mental illness. Irrespective of diagnosis, what are the regions that are most heavily implicated across mental illness? Take a guess. The dorsal anterior cingulate and the anterior insula. So this is very promising, you guys. I think we're clearly modulating functional connectivity within the brain salience network. It's going down after you float, okay? But this is the most important part. We're hitting the very circuit that we think is vitally important for mental health. In the field of pharmaceuticals, they call this target engagement. And this is very preliminary, but we think we're engaging this target in a very active way. And then the degree of reduced post-float connectivity was correlated with the degree of post-float anxiety reduction. And this could be a potent biomarker for actually studying the anti-anxiety effects of floating. So to wrap things up, this is where we're headed. There's a lot of studies going on. I'm pleased to announce LIBR has finally started clinical research. We had to get our feet wet, so to speak, with healthy brains, learn a lot about how to do this research, but we've begun some pilot trials. PTSD, panic disorder, and anorexia nervosa are some of the populations we're working with now. And actually, later today, you're going to hear about the first data coming from the anorexia nervosa study. We're looking at combination treatments as well. We're starting with just floating, but we're also interested in combining things. One of the things I'm particularly interested in is meditation and teaching patients how to breathe in a very particular way while they're floating. And one of the things this requires is actually very precise sound. So if there's any audio gurus in the audience, please come see me because we're trying to get the sound perfect in our float pools. And then, this is the exciting part. Typically, in the field of mental illness research, you study how to get people from, -3 back to 0, how to get rid of their symptoms, right? Floating does a lot more than that. Floating enhances mental wellness, and this is something I think we have the opportunity to do above and beyond just saying we're getting rid of symptoms. We're actually giving people greater happiness and well-being in their life. And we're interested in trying to understand how this works, how long it lasts for. Beyond just clinical research, we want to know the basic science. How could we characterize this relaxation response? I think a lot of you are going to be excited about the study we're going to present next year at the conference. We're measuring magnesium levels before and after floating longitudinally. And Shoshana Liebner was critical in helping us get funding from the Epsom Salt Council to pursue this. But next year, we're going to be able to actually unveil how much magnesium the body may be absorbing during the float experience. We're also very interested in the physiology, what's happening in the heart, what's happening in the lungs. Later today, you're going to hear a talk about how we're measuring all of these different variables. And we have many fMRI and EEG projects still to come. In fact, we're going to be submitting the results I just showed you today for publication in the next few months. And if any of you are interested in keeping up, we just added this to our website. It's an email list. You sign up, and when the study comes out, I'll email you a copy of the study. So please feel free to sign up on our website for the email list. So, when I look at this on the horizon slide, it's daunting. It's like, how the heck are we going to do all this? But the truth is, as you guys know, it's about creating a community. This is what floating is about, and research is no different. And over the past few years, I've been so lucky to have a community of people supporting our lab and the research in our lab. This is just a few of them. You have Saib and Martin and Kyle. Those are the researchers I work with on a day-to-day basis. But then you have people like Ricardo Gildacosta, who's going to come give a talk tomorrow on EEG and floating, who came out of the woodworks and now is an integral part of our lab. And you have people like Jim Hefner, who you heard from this morning, that are helping us conceptualize how this could actually help the industry. How could the research we're doing actually benefit what you guys are doing? And you have a whole slew of people, too numerous to name, that have come through and really provided the community we needed to do the research and answer the big questions. And the truth is, none of it could have been done without the lab, the people who come in every day and do the research. You have Kaylee, you have Obata, Pan, Will, Colleen, Aisha, Gati. And I could tell you the Float Clinic and Research Center is an international endeavor. We have representation from every corner of the planet up there. And our most recent addition is Pan Lin. He arrived here 3 weeks ago from China. In fact, this is Pan getting off the airplane. All he had was a suitcase in his hand and a backpack. He left his home, his family in China to pursue this research because he believed in it. It was a 2-year process to get Pan over here. But I'm so excited that the next talk is going to be Dr. Pan Lin. So thank you guys. I'm so excited to present these findings. You're the first people to see them. Haven't presented this data anywhere else because we only discovered it about 2 weeks ago. But without further ado, please welcome Dr. Pan Lin.